Okay, good morning class, you're on to MAMU with Jarvis, and today we'll continue with our grade 8 experience. And here in MAMU we have a concept we're trying to work with. We don't have mathematics. What we have we call algebra, geometry and arithmetic. So today we'll be dealing with geometry for grade 8, and the topic under consideration is quadrilaterals. Quadrilaterals. It's important for us, before talking about quadrilaterals, to understand clearly what the subject or the matter of geometry covers. Essentially, geometry talks about shapes. Every time we mention geometry, what should come to our hearts should be what? Shapes. Our textbook of reference will be the New General Mathematics for JS2, and also my most treasured textbook, the Essential Mathematics. In fact, for this topic, we'll be using the Essential Mathematics more because of its in-depth knowledge of this matter, right? Now, what is geometry? We said that geometry studies shapes. Geometry studies what? Shapes. So, by way of definition, I'll write a simple statement. Geometry studies shapes. That's quite simple, but it's way more than that. Now, when we talk about the study of shapes, as different from, let's take our hearts a little away from geometry. There's also what we call geography. Graph, description. So geography talks about the description of the earth. So the word geo still comes talking about shape, but here in geometry we are concerned with shapes. So the big question will be, how many types of shapes are in existence? 2 major categories. Number 1, types of shapes. Number 1, we have what is called plane, spelled this way, and number 2, we have what is called solid. And if you like to be an IT guru or whatever, you may want to talk about 2D and what? 3D. So when we talk about plane shapes, what essentially are we talking about? We're talking about a shape that is described in terms of the area covered. And that will be in terms of what? Length and what? Breadth. For instance, I have this book. The flat surface I can see is an area. And this surface I can see is called a plane shape. Looking more like a shape we call what? A rectangle. When we talk about solid shapes, we are talking about a shape that can hold volume. A shape that can hold volume or can hold matter. For instance, your packet of sugar, your Milo, your Bonvita, your Kellogg's. That gives us an idea of what a solid shape would look like. But that's not where we are delving into. We are more concerned with plane shapes because that's where our scope is. But we're doing this to help you understand different dimensions of geometry you need to see. The last dimension I want you to see borders around the aspects of geometry. What are the aspects of geometry? Number 1, we have what is called, in no particular order, formal geometry. We have what is called mensuration. We have what is called construction. And I have another group I have added here because of the way we are working. I call it trigonometry. Trigonometry. Very quickly, what is this? Formal geometry, using logical proofs to show properties of plane shapes. Mensuration talks about aspects of geometry that is concerned with length, area, perimeter, and volume. That's what we are concerned with in mensuration. Construction, using your compass, your ruler, your set square to be able to produce shapes on a plane sheet. Trigonometry. This one, as the name implies, concerns itself with the triangle, especially as it has to do with the lengths and the angles of the triangle. I'm just going to give you a little summary on all of this. It's deeper than this, but we'll just cope with this and then we'll move to our work for today. Now, today we are concerned with quadrilaterals. A quadrilateral is a type of plane shape. A quadrilateral is a type of plane shape. Now, look at this. When we talk about plane shapes, one big family comes to mind, and that family is called polygons. A quadrilateral is a member of the family called polygons. And what is a polygon? A polygon is a plane figure with at least a plane closed figure with at least 3 sides. So that would suggest that the lowest or the smallest member of that group is called a triangle. So let's look at the family of polygons now. The first member is what we call the triangle. The triangle has what? 3 sides. Is that not? Sorry, this introduction is very important so that you have an idea of where we are going to. The next one we have is the one we have been asked to do today is called the quadrilateral. And the word quad means 4. The word quad means 4. Laterals means sides. So quadrilateral means what? 4 sides shape. Just like we're talking about triangle, it means 3 angle shape. Are we getting it? Alright. Now, this will be 4 sides. Now we also have another which we call the heptagon. Heptagon will suggest what? 5. Beautiful. We have another we call the that will be 6. Hexagon. Hexagon will suggest what? 6. And number 5, we have, I'll stop here, we have what is called what? Heptagon. There's so many of them. And there are 7 sides. We will be coming to look at this again when we handle the topic called angles in a polygon. So this is just a teaser, or more like when you're watching a movie, you say this is a trailer, a teaser, an Easter egg. The Marvel Cinematic Universe, they do that a lot. They just give a little hint of what is to come later. So this is just a little hint of what is to come later. But our focus will be what? On the quadrilaterals. Alright, so with that said, a very interesting question I want to ask. If quadrilateral is a member of the family of polygons, how many children has quadrilaterals? Alright, we've just tried to do introduction to the topic and now we go into quadrilaterals. So types of quadrilaterals. We said a quadrilateral is any plane figure or a polygon with 4 sides. We can't talk about a shape except it is what? closed. So 4 sides will define the quadrilateral. So let's try to look at what are the types of quadrilaterals. Or should that be examples of quadrilaterals? What are the examples of quadrilaterals? Number 1, we have the parallelogram. Number 2, we have the rectangle. Number 3, we have the square. Number 4, we have the kite. Number 5, we have the trapezium. And there's one I'm supposed to have named before now, the rhombus. And I think these are the basic ones. There could be others, but these are the basic ones you get to see in most modern text books. Parallelogram, rectangle, square, kites, trapezium, and your rhombus. In looking at these types or examples of quadrilaterals I've listed, an essential aspect of the work is to be able to identify the type, and also to be able to tell the properties of the type or example we are looking at. So I'll start by looking at one that we're already very used to, and that is called the rectangle. Let's start with the rectangle. So what do we know about the rectangle? I'm going to try to draw that. So that's what we have on the board. This is a rectangle. Let's have it properly drawn. Okay. So that's the rectangle on the board, and we will be trying to look at the properties of a rectangle. What are the properties of a rectangle? We'll go back and look at what we can remember. Number 1, we know that opposite sides are equal. Now, when we talk about opposite sides, this is what we mean. That is, this opposite side is equal to this side, and this side is equal to this side. So it has 2 pairs of opposite sides, and they are equal to one another. This is equal to this, and this is equal to this. Another interesting thing we know, I've left out something very important, but I'll see how I can fix that in the course of our work. Now, another interesting thing we should take note of here is that the angles are 90 degrees each. The angles are what? 90 degrees each. Notice that I'm trying not to write so much. The angles of a rectangle are all each 90 degrees. Another important attribute we see from a rectangle is when we try to cut the rectangle. Now, we look at the concept of symmetry. Concept of what? Symmetry. This is one line of symmetry, and this is another line of symmetry. And the begging question would be, what then is a line of symmetry? The line of symmetry is an imaginary line which we picture and enables us to cut the shape into 2 identical halves. So what that means is that if I cut the shape in this manner with the line of symmetry, what I have here will be exactly what I have here. If I cut like this, imaginarily, okay, we looked at opposite sides are equal, the angles are 90 degrees each. We're looking at it having what? 2 lines of symmetry, 2 lines of symmetry. Now, this is a very important property of a rectangle. A rectangle has Two lines of symmetry. Two lines of symmetry. Alright, so now another important attribute we'll just quickly look at is that if you watch this carefully, it cuts like this, and the intersection of the lines of symmetry may not be a distinct property, will give you 4 other rectangles. I see it. 4 other rectangles. If we imagine that we're using this line of symmetry to divide. So these are the 3 basic distinctive properties. Okay, very important. Diagonals. Yeah, diagonals bisect themselves. Now, the big question here is, what's a diagonal? The diagonal cuts like this, and it will cut like this. I seen it. Diagonal will connect opposite sides, and so the diagonals will bisect themselves. So it will cut in this way, to cut in this way, and it will cut this way, and it will cut this way. Alright? 4 cuts. Okay, the diagonals bisect themselves. So this is a diagonal. This is another diagonal. What's going to happen is that this will cut this into 2 equal parts, and this one will cut this into 2 equal parts. So what you have is that the diagonals will do what? Bisect themselves. But be careful to note that this bisecting of themselves, the angle is not at 90 degrees. Take note of that. So if you watch carefully, other properties that we may not list out that you also observe here will be this. It will bisect this angle. 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 Now, another important attribute that we did not take into consideration, but we're going to see it when we come into the parallelogram, will be that, we said that opposite angles are what? Opposite sides are equal, but all the angles are 90 degrees. When we come to the parallelogram, what you notice is that the opposite angles are equal. See what's happening? I always imagine a parallelogram as, a rectangle is a special type of parallelogram. Please, let's write that down. A rectangle. So another property we can take note of is that it is a special type of parallelogram. It's a special type of parallelogram. I hope you know that this side being equal to this side would mean that, and this side equal to this side would mean that this line is parallel to this line, and this line is parallel to this line. Although we don't talk about that, but remember that any property that is applicable to a parallelogram will to an extent be found in a rectangle. So we say that a rectangle is a parallelogram, but a parallelogram is not necessarily a rectangle. I'll come again. A rectangle is a parallelogram, but a parallelogram is not necessarily a rectangle, because a parallelogram can take different arrangements, but the rectangle is just one special type of the parallelogram. So that's for a rectangle, and then we'll move on to a square. If you're very observant, you'll notice that initially I do this as a general property, but if you watch carefully, you discover that this will be equal to this. Is that not? Yes. And this will be equal to this. I hope you know that their diagonals are equal. Is that not? Diagonals are equal. So add that. Diagonals are equal. That's why we said that a rectangle is a special type of what? Parallelogram. The diagonals are equal. And if the diagonals are equal, when we cut, we're going to have 4 triangles that are not equal, but such that this triangle will be equal to this triangle, and this triangle will be equal to this triangle. Sometime later in your maths, you're going to be taught something we call congruency. This triangle will be congruent to this, and this triangle will be congruent to this. Don't bother trying to understand that for now. With time, you get to understand that better. So we run over the properties again. Opposite sides are equal. This is equal to this, and this is equal to this. The angles are 90 degrees each, meaning that this is 90 degrees. This is 90, this is 90, this is 90, this is 90, this is 90. There's something I don't want to talk about. I'm going to talk about that very soon. Now, we have that it has two lines of symmetry. We have two lines of symmetry. Then we have that diagonals bisect themselves. And because diagonals bisect themselves, it's important to note that the diagonals are equal. It's a special property that differentiates the rectangle from a conventional parallelogram. What other property can we get out of there? We also know that it's a special type of parallelogram. So in practice, we say that the rectangle is a special type of what? Parallelogram. At this point, let's digress a little and quickly look at something I left out. Properties of quadrilaterals. There are certain things we expect a quadrilateral to have. Number one, 4 straight sides. 4 straight sides. Number 2, 4 angles. Number 3, the sum of the angles of any quadrilateral is what? 360 degrees. So the sum of the angles of any quadrilateral is 360 degrees. Number 4, by this extension, the sum of the exterior angles of any quadrilateral is also 360 degrees. Take note of that. You're going to see this property in subsequent work. Now, number 5. They all have 2 diagonals. That's another very important property of equilateral. They all have what? 2 diagonals. So we try to go over the properties once again. Number 1, we said there are 4 straight sides. Number 2, we said that they have 4 angles. Number 3, we said that the sum of the angles of any quadrilateral is 360 degrees. We have also said that the sum of the exterior angles of any quadrilateral is what? 360 degrees. We also said that they have what? 2 diagonals. The other properties you can figure out as you go deeper in studying quadrilateral. But for now, we'll just restrict ourselves to what the essential ones and the ones we can really remember now. Alright, so we'll leave this now and go on to look at squares. So for a square, we imagine a shape like this. All the sides are equal. I'm just using this to show that all the sides are equal. Now, some of you will notice that I just put 90 degrees here and I put 90 degrees here. Now, in drawing shapes, once I indicate this as 90 degrees and 90 degrees, this must be 90 and this must be 90. Hence, all the sides are equal. So, I don't necessarily have to put 90 degrees in all of them. I was expecting somebody would have asked the question on that earlier. So all the sides are equal. So let's look at the properties. Properties of a square. We've looked at a rectangle, and I'd like to start by saying that a square is a special rectangle. Number one, a square is a special rectangle. This information I'm giving is so important because I don't know that they do that so often now. In NECO BECE, which is what we write for JS2 in Nigeria here, what happened is this. There are questions that will ask you whether this is this. So that's why I'm taking pains to mention this. Is a rectangle a parallelogram? Yes. Is a square a rectangle? Yes. Is a square a parallelogram? Yes. Because a square connects to a rectangle and a rectangle connects to a parallelogram. So you need to see this connection. That's the objective of this topic. You need to see the connections as we are making them. Right, so the first thing I said there is that a square is a special rectangle. Number two, all sides are equal. All sides are equal. Number three, all angles are equal and are 90 degrees. I just said here all angles are 90 degrees. The implication here also is that all angles are equal and are 90 degrees. So that's what that will mean. Number four, what other properties can we get out of here? We can look at the lines of symmetry. So we have 4 lines of symmetry. 4 lines of symmetry. Now let's identify the lines of symmetry. The diagonal position is a line of symmetry. The other diagonal position is a line of symmetry. This cuts like this, another line of symmetry, and this cuts like this, another line of symmetry. So we have what? 4 lines of symmetry. Another important thing we should note is that the diagonals are equal. Diagonals. I don't need to tell you that there are 2 diagonals because I've told you that from the general properties of a quadrilateral. It's a general property we expect. So the diagonals are what? Are equal. Diagonals are equal. Diagonals are equal, and added to that, diagonals bisect each other. Diagonals bisect each other at 90 degrees. They bisect each other at what? 90 degrees. So the angle they form will be what? 90 degrees. Another important information I'm going to give to you here is this. A square is also a special rhombus. A square is a special rhombus. I'm going to pause the class at this point. The beautiful thing about learning is that we try not to give you all the information. Curiosity is the mother of invention. It is curiosity that has brought us to a level where we invent and bring things to life. So I'm going to stop the class today intentionally and trust that you will go back and figure this thing out. 2 important things we have said about a square. A square is a special rectangle. And we also said that a square is a special rhombus. Food for thought. MAMU with Jarvis will close out for today. Join us in our next class. Thank you.